let's see what we got here. Okay, so in our setup, we're going to look for N, P, and P hat. What is our N? 200. P? 0.4737. P hat? 0.60. So this is what we see, okay? When somebody plays roulette a bunch of times, we're expecting them to win only 47% of the time. This person won 60% of the time. So what's the probability that something like that would happen just from random chance? That's what we want to know. Okay. Well, we can do our standard error calculations, which we actually did already, but 0.4737 times 1 minus 0.4737 divided by 200, and yeah, 0.4737 times 1 minus that divided by 200, square root of that, 0.0353. Okay, and we get our z-score. We're going to do z is 0.60 minus 0.4737 divided by 0.0353. Okay, so I'm going to do 0.6 minus 0.4737 divided by 0.0353, and I get 3.57 or 3.58. Does that seem reasonable? Maybe because of rounding, your numbers are a little bit off, but something around 3.5, something a little bit more than that. Okay, let's go to our z-table and see what we have. It's not even there, right? Okay, you go z goes to 3.4, 3.49 is the largest thing we have, okay? So 3.58, we are over 3.5 standard deviations away from the from the mean, okay? So we are literally off the charts here. And so what we know is that the area to the left is something around 0.999767 or even more than that, okay? So I'm going to just say 0.9998 over here because the z is off the charts, okay? Okay, 3.58, that's not on the charts. So we know that the area to the left is a lot, okay? Almost 1, okay? So I'm just going to say 0.9998, okay? That's the last value that I have right here, okay? Or, you know, if you had z is 5, it's even that much further away. Okay, so if somebody played fairly, what's the probability that they win 60 games out of 200? What's the answer there? 0.0002. Okay, so now you have a decision to make. If you are the casino manager, you have a decision to make. Is it possible? Is it possible that he's playing fairly and he happened to get really, really, really lucky? Yes. It is possible. How likely is that to have happened? Very unlikely. Okay? So is it possible? Yes, it's possible. Is it likely? No, it's incredibly unlikely. You don't know. You are not the person playing. You are the casino manager and you have to make a decision. What is the decision you make? You say, well, I'm going to give you the benefit of the doubt, even though it's incredibly unlikely that you got this lucky. We don't want to accuse you of cheating, okay? Or you say, maybe you are playing fairly, but it's so unlikely that for this to happen that I'm willing to say, I don't think it happened by random chance, and I think you're doing something shady, okay? What do you guys decide? He's doing something shady, right? It's so unlikely that, I mean, it's possible, but you just say, please don't come back here again, okay? Why don't, you know, or, you know, we'll try to figure something out, okay? So this probability, 0.0002, this is the p-value. This is the probability. Okay, let's just keep in mind what this is. This is the probability of a fair person, or, yeah, we'll say it, of a fair playing person. I don't know, what is, let me just change this. This is the probability of a person playing fairly. Okay, person playing fairly will win 60% or more games out of 200. Okay, so yes, it is technically possible for someone to win this much by chance. Okay, but it is so unlikely, to happen that we conclude he is doing something shady. Okay, let me save that.